We use nuclear equations to represent radioactive decay. In radioactive decay, an unstable nucleus becomes more stable by emitting an alpha or a beta particle, or by giving off a gamma ray. Firstly, we'll look at the radiation that gives off an alpha particle. An alpha particle is identical to a helium nucleus, being made up of 2 protons and 2 neutrons, and so is represented by the symbol shown here. If we take an example of an unstable nucleus, such as radon-219, we can see what happens when an alpha particle is emitted. As the alpha particle is emitted, a new isotope will be formed. To work out the isotope formed, we need to use the fact that the numbers on each side of the equation should balance. The numbers at the top represent the total number of protons and neutrons before and after the change. These should be equal on both sides of the equation, and so we know that the new isotope formed has a relative atomic mass of 215, as 4 plus 215 equals 219. The numbers along the bottom represent the total number of protons, and again both sides of the equation should balance. Therefore, the new isotope formed will have 84 protons. As the number of protons have changed, we now have a new element, and looking this up on the periodic table, you can see that this is polonium. Overall, the alpha decay has caused a change in the mass of the nucleus, as the top number has changed, and it's also caused the charge of the nucleus to decrease, as it's lost 2 protons. To work out the nuclear equation of a beta particle is very similar to the previous example. However, there are a few differences. A beta particle is a high-energy electron emitted by a nucleus that has too many neutrons compared with its protons. As an electron has a relative atomic mass that is effectively 0, the top number is a 0, and as it has a relative charge of -1, that becomes the bottom number. If we take an isotope, such as that of carbon-14, we can see that it will decay to produce a beta particle. Again, those numbers on each side of the equation need to balance, so the new isotope formed will have a relative mass of 14. Additionally, the bottom numbers also need to balance, so the proton number of the new isotope will have increased by 1, as 7 added to -1 will give the original 6. Looking this element up on the periodic table, you can see that it's nitrogen that has 7 protons. Overall, a beta decay will not cause a change in the mass of the nucleus, but does cause the charge of the nucleus to increase. For the final emission, that of a gamma ray, there is no nuclear equation to write. This is because a gamma ray is uncharged and has no mass. Therefore, when it is emitted, it does not cause a change in the mass of the nucleus, and it does not cause a change in the charge of the nucleus either.